Hey everybody, welcome to Bill Sky, the database guy, and it's been a while since I've done a database video, and the reason is because databases are not easy. I mean, some of the databases like NoSQL databases, Mongo database, things like that might be easier, but it's arguable, they're not as efficient, they're not as protective, they have a lot of redundancy in them, and we're going to be talking about all that. But what this video is going to be doing is we're going to be talking about how to design a relational database. And designing a database is so incredibly important. You don't want to design a bad database, then add billions of bytes of data to that database, find out you designed it incorrectly. Now you're going to be forced to write programs to fix the problem, be forced to write even more programs to convert the data. Then you're going to have to write a script or a program to redesign the database, and then you're going to be exposed to database downtime. Yuck, you just don't want to do that. So it's really important to design a database correctly and really have a lot of thought about it, even run it by a lot of different people. You know, how does this look? Do you see any problems with this? Database design reviews, very, very important. And this is important for every type of database out there. I mentioned NoSQL databases like Mongo database, which is a JSON database. It's even important for that. It's important for relational databases, which is what we're going to do today. It's important for networked databases, which aren't as used as much these days, but they still are out there. A hierarchical database like IBM's IMS database, you still need to design it correctly, and a lot of what we're going to be talking about are going to be applying to all of these, as well as NoSQL databases. So everything you do when you design a database, you want to make absolutely sure that you design it correctly. Now, this is going to be a very informal database design video. I'm going to have additional videos in the future talking more about the science, the relational science behind all of this, but we're just going to get our hands dirty and actually do it. So we're going to talk about actually doing it. We're not going to talk about things like first, second, third normal forms, Boyce code normal form, fourth normal form or higher. These are all ways to make sure that your database is not creating a redundant data, but also the higher you get in these normal form numbers, the more poor performance your database could see. So you want to actually make sure that you design a database to not only be non-data redundant, in other words, you're not repeating a lot of data, you don't have a lot of the same data in multiple locations, but you also want to make sure that it performs well. So let's jump right into it. Okay, so what are the four important concepts when designing a database? You want to make sure that you identify the data like you would an object in an object-oriented programming language. You want to define a unique key. How do you identify the thing? Kind of like your social security number or your student ID or employee ID. You want to define that unique key. What can you do to reduce or eliminate data redundancy? Deduplication, like I like to call it. What do you want to do to make sure, absolutely sure, that you don't have the same data in multiple locations? Very, very bad, not only for performance, but even more so for data storage. Because you don't want to keep buying more and more storage because you've got duplicated data. That can get expensive. What can negatively affect performance? And if you think about these four important things while you're designing a database, you won't have to necessarily go to this fourth normal form, Boyce code normal forms, because you're going to be thinking about it. It's going to be second nature. And that happens to me all the time. Designing a database is really second nature to me because I've done it for so long, so I don't really have to go through all these phases. We're not going to do that today. We're going to do it as if we are going to keep all this in mind while we're designing the database. So what are some of the components of a relational database design? Well, we have the database itself. Some products call it a schema, like MySQL, it calls it a schema. That's what we're going to be using today. So you've got the actual database itself, and the database is going to contain all of the data necessary to do the work that you need to do for that type of data. So we're going to create a database called sales, and we're going to add all the different things in that database that affect sales, or that can be used to process sales. I don't know, like Amazon or Etsy or something like that, some online system. Even non-online, it could be a face-to-face. You're still going to have the same type of a design. So you've got the database itself. Then you've got the tables that define each object within that database. They're also called entities. So that object might be customer, might be product, might be supplier, might be order, might be an order item. We're going to be touching on all of that stuff. Not on this particular video, because this is the first video on designing a database. So we're going to be, but we are going to be talking about a few of them. And then you've got columns or fields or attributes, and that's each piece of data for each object in the actual table. So for instance, I'm an object in the table, I'm a customer, I have my own address, my own phone number, my own email address, my own credit card, but my wife may have a different credit card number. She may have a different gender, which she does. She may somebody else in there. So each row of the table, or tuple as they call it in the science of database design, each row will have all these different attributes to define that row. We're going to see that. It's kind of like a spreadsheet. Each row is in the spreadsheet defines that entity. And then you also need to create what we call a unique key or a primary key, and that key is used to identify uniquely that particular row in the table to make sure you can access it quickly. And you want to make sure, another thing about a relational database, you want to make sure that each table contains only data about that object. I don't want to put information in my customer table that has information about the power company. That just doesn't make any sense. So you need to think about that while you're designing your database. And then also, there's this idea of relationships. How are two or more entities connected in the design? So we're going to take a look at all of that. So let's go ahead and let's start up our MySQL Workbench. And you can use anything. I'm going to be showing you guys the actual data definition language, the actual SQL that's used to define all these objects. But what we're going to do is we're going to use MySQL. A lot of this is the same in every other relational database system. In fact, I would say it's the same. And I'm just going to do it on the local instance of my MySQL. Okay, now when you start up MySQL Workbench, you might actually have the administration tab selected. So you see things like server status, client connections, users, and privileges. Well, that's not what we want to look at. We want to look at schemas right now. And a schema is basically a database. You can think of in MySQL, schema equals database. And it's actually got a lot of historical meaning to it, the word schema. So what we're going to do is we're going to create a new schema. And the way that I'm going to do that, I'm going to just right-click over here under schemas, and I'm going to say create schema. Under that, I'm going to say schema name. I'm just going to call this sales. So I'm going to create a sales database. Now there's other things that you might want here. You might want to pick a different character set if it's going to be used in a different country, or if it's going to be used in multiple countries, you may want to pick a different character set. Collation, we're not going to be talking about that in this video, but you just keep the default character set and then click apply. And what happens is, one thing I really love about MySQL Workbench is it actually shows you the data definition language. That's from my IMS days, DDL, but you can also call it that. It means how am I defining my metadata? How am I defining the actual definition of the data? Not the actual data itself, but the definition. So I call it DDL. You'll hear me use that a lot. But actually, this is SQL that says create schema sales. So this is something you could do from the command line. This is something you could put into a script if you need to create the database on a customer's computer. Like let's say you're going to be creating a sales management system and you don't want to have to go out there and type all this stuff in. They're not using MySQL Workbench. Oh my God, how do I get that to them? Well, MySQL Workbench is great. So what I'm going to do is I'm actually going to bring up my favorite editor. And you can do this on Windows. It's actually done exactly the same way. And I'm going to create a new file. And as I'm creating the database, I'm going to go ahead and just select that, copy it, and I'm going to paste it in my little file here. And I'm going to save this file. I'm just going to call it sales definition.sql. So these are all the SQL statements I'm using to create the database and the tables and all that. We're going to see that in just a moment. And this is a great learning tool as well. So I'm going to come down here and click apply, and it said it was created successfully. I'm going to say close, and notice we now have a sales schema. Now, when we open up the sales schema, you can see we have tables, views, stored procedures. We're not going to mess with any of those other than tables. So what I'm going to do is I'm going to click on tables, and what I want to do now is I want to create a customer table. Because we have a sales database, we're going to create a bunch of entities that have to do with doing sales. And the first thing you need really, well, maybe not the first, but one of the important things you need are customers. So I'm going to right click on tables, and I'm going to say create table. And you can see we kind of have a little, it almost looks like a spreadsheet here, but I'm going to give it a table name. I'm going to call it customers. And actually, oh, no, that's the column. We're not there yet. I want to come up here to the name, and I'm going to say customers. So that's my customers table. And it belongs to the sales schema. Perfect. That's exactly what we want. Then the next thing we want to do is we want to create the columns that define the attributes for that customer. What's one of the very first things you think of when you have a customer? Well, you have their name. And then you come over here to data type and you specify what is the data type. Now I'm going to drop it down and you can see all the different data types. And there just really are a lot. Now it's very important to think about what data types you want to use because you may want this schema to be able to be transferable to another database system. So we're going to stick with the first 5 up on top, and we're going to talk about what each one of these are, but you have to pick the appropriate one. So for name, it's not an integer, it's not a decimal, it's not date, time, and it's not a binary object. That's what a blob is. It's a binary object. It's basically a char. It's a character object or a character field. Now what is varchar? Varchar just means variable length char. So it's kind of like a string in C++. So I'm going to pick varchar, and within there I'm going to say, well, the name is never going to be longer than 64 bytes. So I'm going to say varchar parentheses 64 bytes. And then you've got some of these little keys over here, or these little checkboxes. Is this a primary key, which we'll talk about in a little bit? I'm going to turn that off. NN means not null. It means it must be filled in. If you don't fill it in, the database, when you try to add the data to the table, the database is going to give you an error. So we want NN to be checked in this case. Not all cases, but in this case. UQ means, is it unique? Well, think about it. Can the name be unique? Tom Smith, Tammy Baker, Tammy Baker? No, multiple people are going to have the same name, so it's not really unique. Is it binary? And there's a bunch of other ones here we're not going to talk about in this video. So whenever you're creating an attribute or a column, you want to make absolutely sure you pick the right data type and whether it should be unique, not null, or a primary key, which we'll be talking about next. Okay, so let's create another one. So I just double-clicked right below the name, and I'm going to say address. Now address, again, that's varchar. It can have multiple lines. So let's just call this, I don't know, 128. And it doesn't have to be, it doesn't have to be filled in. Maybe you've got a customer that they just want to do pickup, so they don't want their address in the system. So we're going to leave that not null blank. Okay, the next one is going to be phone number. Now you have a choice here, phone number. Well, maybe phone number might be good as an integer. So I'm going to drop this down. I'm going to click integer, and we'll see if that's a good choice. Okay, the next one will be, I don't know, credit card? Credit card number? I think credit card number might be a good choice for integer. So let's leave that there. Let's make that integer. And then for online sales, you always have an email address. So we're going to call that an email address, and let's leave it as a varchar. Notice it defaults it to 45. I'm going to make it 65 just because there can be some pretty long email addresses out there. And it must be not null. And it must be unique because you can't have 2 email addresses that are exactly the same. So we're going to make sure that that's unique. Okay. Now, if I go ahead and I press apply, look at what MySQL Workbench does for us. it shows us the actual data definition language, the actual SQL necessary to create this table. Now, I'm not going to click apply here, but take a look at what we've got here. It says create table sales. Sales is the schema dot customers. So that's going to create the table customers. There's going to be a name column. There's going to be an address column. There's going to be a phone number column, credit card, and email address. And take a look right what we have here. MySQL actually created another thing saying unique index. That means that MySQL figured, okay, that is a not null. That's like the only not null. Well, actually, it's not the only one. Name was as well. So I'm not really sure why MySQL picked email address, but it's going to make it an index. Now, an index is something that is used by the database to quickly be able to access data in the table. If you don't make it an index, you can still search on it, but it'll take a lot longer. We're going to talk about indices later in another video. And I'm just going to press cancel right now because we're not done yet. One of the columns here is called primary key, and we haven't done anything with primary key. Now, what is a primary key? A primary key is a field inside or a column in the table that is unique to that, in this case, customer. So I already mentioned name. Is name unique? Nope. You can have 2 Tammy Bakers. You can have 50 Tammy Bakers. If you got a really big company, you have 10,000 of them. So we can't really use name as unique. Can we use address? Well, maybe, but what if there's 10 people in the same house or the apartment building or the condo building that all have the same address? Well, that's not going to be good either. Phone number? Well, maybe. Cell phones, that's much closer. Cell phones might be a good unique or might be a good primary key. But what if somebody doesn't want to give you their phone number? You can't do that. Maybe you might have somebody like a home phone number. Let's say a landline, which a lot of people don't use. I have one because it's very convenient. And if the power goes down, I still have communications. However, that is a very good example of how a phone number is almost like an address. You can have multiple people living there. What about credit card number? Well, credit card number might be good, but it might be shared within a family. You might say, oh, brother, that's not going to happen. Well, it will happen, I promise you. So let's try email address. Email address, well, I shouldn't say everybody has an email address, but most people, I think pretty much everybody on the internet has an email address. People normally don't share email addresses, especially, they just don't. It just isn't shared very much. And most people will give out their email address because it's not as much of a problem if somebody sends you an email as if they constantly call you. And also spam filters can root out spam from email, where on a cell phone that's not as easy. So I think email address is a good candidate for primary key. So I'm going to click that. Now there's some argument as to whether email address is the perfect one. We might want to actually create another column called customer number. And we might just want to make that one an integer. So we could do something like that, and we can make that the primary key and not null and unique. So we could do something like that. The problem with customer number is that the customer has to remember their customer number. You have to remember their customer number. Where email address is something that just about everybody remembers. Also notice I can create 2 checkboxes for 2 columns in the table, saying that those are both primary keys. That means together they're primary keys, concatenated together. So I'm going to go ahead and get rid of customer number. So I right click on it. I'm going to say delete. And we're just going to stick with email address. So email address must be unique. It cannot be null. And it is the primary key. Now I'm going to click apply. And you can see how things have changed. We now have a new primary key line in the SQL, or in the data definition language, that is based on the email address. So I'm going to go ahead and select this, copy it. I do this for every database I create. I'm going to paste it into my file. I'm going to save my file. So now I have all of the statements that I've used. And also, you can go and look all these up. What do all of these do? Now, there's also some things you can do. You can specify the algorithm. You can specify lock types. We're not going to mess around with that very much because this is just an introduction to database design. So I'm going to go ahead and click Apply. And it said the script was created successfully. So now I'm going to close this tab, I'm going to close this tab, and I'm going to open up my tables, and you can see the customers table there. I'm going to right click on that, and I'm going to say select rows limit 1000, and you can see the actual SQL statement to grab data out of that table. Select asterisk from sales.customers. Sales dot is the schema name and customers is the table name. But you can also see down here that it's empty. And we're going to add a little bit of data later on. Okay, so we created our table. We created, well, what else could we do here? Because we created customers. Now, if I want to look at this definition, I can right click on it and I go to Table Inspector, and you can see all kinds of information about the table. One thing that is a little bit wrong in this design, well, there's a lot of things that are a lot wrong with this design. But one of the things that's a little bit wrong is that credit card number, you're only allowing the customer to have a single credit card number. And it's actually not a good idea to only require to have a customer only be able to use a single credit card number. What if you wanted to have multiple credit card numbers? Well, okay. What I would like to do is I'd like to show you something that MySQL Workbench does very, very well. And I would like to take what we have right now and convert it into a database design diagram. So what I'm going to do is I'm going to come up here and say File, New Model. Okay, here's my model. And what I want to do is I want to say Model, and let's find it. I'm going to say Database, reverse engineer. What that means is that take a current database and reverse engineer it into my model. And you're going to see what I'm talking about right there. So I'm going to say reverse engineer. I'm going to do the local instance. Put in my password. Next. And now it asks me what database that I've defined already would I like to bring it into my database model. Now we really should have started with this. We shouldn't have automatically started doing it in the DDL. We should have done it in the database model. And that's why we're having to come backwards. And the reason we're doing this is because we need to make some changes, and it's actually pretty easy in the model. So I'm going to click on sales. I'm going to leave these other two. You shouldn't have those unless you installed the sample databases in my installation videos. But I'm going to click on sales only and click next. Next. And go ahead and just leave everything default. Next. And close. And here we go. So here's our model. This is really neat. I really love database design tools like this. Okay, so instead of doing it at the level of the physical model where we're actually implementing into the database, we're going to do it in this model. Now, I was talking about credit cards. I think it would be nice for a customer to have multiple credit cards. And a credit card is not necessarily dependent upon the customer. What do I mean by that? Well, the customer can die, but the credit card can still be valid. It can still exist without the customer. Now, set aside the legalities of that or the criminality of that, but a credit card can exist separate from a customer. So I don't think it's a good idea to have a credit card number in there because we don't have the credit card, the issuing bank, we don't have the credit limit, we don't have any of that information. So what I'm going to do is I'm going to create a new table, and the way that I'm going to do that is I'm going to come down here to this little table icon, and I'm going to click on the model. And what I'm going to do is I'm going to double click on it, and I'm going to call the table credit cards. Maybe I might want to call it payment methods. Ooh, I like that better. Payment methods. I'm thinking about it. And when you create a table in the model, you can also specify the type of data or the type of file system that's going to be used to store that. And why would you ever want to do that? Well, because some tables might be better using different types. Now, different types. And the Workbench is a little bit clunky in that you kind of have to move things around to see everything. I'll probably get a bad letter from Oracle about that. But it's a little bit clunky, so you might have to move things around. And let's do that. Okay, great. Okay. So the engine, that's what the engine is the file system, the type of file system that's going to be used to store that data. I'm just going to leave everything as InnoDB. It's the default for MySQL. And there you go. So there's our table. Now, we haven't created this table yet. This table is simply in the model. We're going to actually create it in a little while. So let's go ahead and add some columns. So just like we did in the physical model, I'm going to say credit. I'm going to say it really shouldn't be credit card number, because if it's a bank account or a debit account, it's not really a credit card. So we're going to call this account number. Now I'm thinking, right? I'm thinking about primary keys and designing as I'm typing this stuff in. So this is going to primary key, not null, and it will be unique, because you really can't have, well, that's arguable. Maybe one bank will have a credit card or will have an account number that's the same as another bank. So maybe account number isn't the best, but let's leave it there for right now. Okay, the next one, we're going to say issuing bank, and we're going to call that varchar, and that isn't really necessary to be to actually be unique, or to be unique or not null. In fact, we don't want it to be unique, because that means that customers can only have a single card or a single payment method from at any issuing at any bank. So we don't want to do that. I don't know, what's some other type? Maybe we might want to say account type, and we're going to make that a varchar 8. So what is account type? Account type, and we're going to say not null. An account type might be, is it a credit card? Is it a debit card? Is it a bank account? Is it a wire? Things like that. You might want to do things like credit limit and stuff like that. But let's just leave it like that for right now. Now, the payment method must be associated with a customer, right? So we're going to come up here and we're going to put in the owner name, and that must be not null. We're going to put in, I don't know, owner address, owner email, and I believe we should probably make that a little bit bigger than 45, so let's make it 65. Okay, so let's take a look at this. Now I want you to look very closely at these two entities, at the customer and the payments method entity. Do we have any columns that are repeated? Well, we have the name. Oops, we have the owner name, same thing. We have the address. Oops, we have an owner address. We have a phone number. Well, we didn't put that over here, but it might not be a bad idea. We have email address. So we have duplicated data already because our design is not very good. And what if the customer leaves? What if the customer moves? Well, if you have the address in every payment method for that customer, that means that if the customer moves, you now have to change it in multiple locations. Ugh, you definitely don't want to do that. So we want to eliminate redundancy. That's one of the things that we want to eliminate. And one of the things that we're going to do here is we're going to go and delete those columns, and I'm going to show you how to add them via a relationship. So I'm going to go ahead and right click on owner name, and I'm going to delete it. I'm going to delete owner address. I'm going to delete owner email. So you might say to yourself, well, how in the world will we equate a payment method with a customer? Well, that's where we're going to talk about relationships. So I always get this wrong in the MySQL Workbench. So I'm going to click on this little dotted 1.n icon, and I'm going to click the payment method, and then I'm going to click the customers. And whoa, look what happened. So it created a line that has a little foot at the end, and what this means is that we have a one-to-many relationship. And what that means is that one customer can have many payment methods. Awesome. How was that relationship created? Well, notice it added a new column or a new attribute in our payment methods table called customer's email address. And it's the same data type as the email address, which is the primary key. So what it did was it created a new column in the payment methods table, which is the same exact type of column as the primary key in customers, and that's what created our connection. Now, because we have a payment method here, do we need credit card here any longer? Nope. So we can actually get rid of that. So what I'm going to do is I'm going to double click on that, and I'm going to come down here. I'm going to click on credit card number. I'm going to right click and I'm going to delete it. We no longer need credit card number. So notice we're saving space already. Also, we're making our design more flexible because now a customer, before we had the payment methods, the customers could only have one payment method, and it was a credit card number. Now we've got multiple payment methods. Now, by no means is this complete, but it's a good illustration as to how you need to think while you're defining your database. Okay, so this looks pretty good. Now, we could also argue that phone number. A customer could have multiple phone numbers. A customer could have multiple addresses. I agree with you. We could have multiple entities here, multiple tables, but for right now, let's just stick with payment methods and customers. Okay, now I'm going to save this model, and I'm going to save it in my documents folder, and I'm going to call this sales schema model.mwb. All right, great. So now that we added this, how do we actually change our actual database? So if I go back in here, you can see that we've got our customer, our sales table. We don't have the payment method table yet because we just did it in the model. We never did it in the actual physical implementation. Credit card is still there. So what we have to do now is we have to go back into our entity relationship diagram here that we just created, and we have to forward engineer it to the database. And MySQL will take whatever's in the model and it'll modify our physical implementation in the actual database. So I'm going to go up to database and I'm going to say forward engineer. It asks me where I want to do it. I'm doing it on my local instance, so I'm going to say next. I'm just going to leave everything default. I'm not going to click on anything. Well, you can look at all that stuff later on. I'm going to click next, type in my password. Now what MySQL is going to do is going to analyze what is in the database right now that we've implemented and what's in the model, and it's going to make changes to the model. And there it is right there. So these are all the DDL statements it needs to actually create or make the modifications. Now I'm actually going to cancel out of that. And what that was going to do is that was actually going to delete my database and then it was going to re-implement it. What I would like to do instead is I would like to synchronize the model. I want to synchronize the model with my physical database. Now, why would I want to do that as opposed to forward engineer? Forward engineer destroys the physical database that we did previously, and because we didn't add any data, that would be okay. But what if you have data in your physical database and you're going to make a change? You don't want to forward engineer it, you want to synchronize it with the model. So we're going to go ahead and say next, next. Ask me for my password again. It's grabbing the data from the database. It says I just want to do the sales database. It's going to synchronize the customer's model with the customer's database entity. So I'm going to say next. And it shows you all of the SQL, all the DDL statements. It's doing an alter table. It drops the column credit card number. Remember we did that? Then it creates in the model we did that. Then it creates the table payment methods, and it does it all for us. So I'm going to say execute. It said synchronization completed successfully. I'm going to close that. I'm going to go back to my local instance tab. I'm going to right click and I'm going to say refresh all, and look at what happened. We now have a payments method table. So we've connected. Now you're not going to see the connection in the actual physical database but you will see it in the entity relationship diagram with this line. How will we see it in the actual physical database? Well, I'm going to go over here to payment methods, double click on that. Right click and say Table Inspector, go to Columns, and you can see the customer's email address. That is the connection to our customer entity. Okay, next thing I want to do is I want to add some data to my tables. So let's add a credit card. So I'm going to right click on Payment Methods, and I'm going to say Select Rows. There's nothing there. So I'm going to go down here to account number. I don't know. Let's just add a bogus account number. Issuing bank, BOA, Bank of America. Account type, we're going to say credit, C, or you could just say CC. Now it's a good idea to come up with standards. What is account type going to be? You don't want to have it for credit card. You don't want it to be credit card here, and then the next one be CC. You want them all to be the same. So that's something we're going to talk about later. But I'm just going to call this credit card, credit C. And now it asks me for the customer email address. Wait a minute. I haven't added any customers yet. Let's say if I try to apply this. It died. The insert to insert the data died. And the reason was because customer email address was null. It was blank. We didn't do anything. Now let's see if we can find this in here. Cannot add or update child row. A file key constraint fails. That means that we tried to insert something with an email address that didn't exist. So let's go ahead and close this, and let's don't save it. And now let's go to customers, select rows, and now let's add a new customer. So we're going to say Tammy Baker. Now, as you type this in, it's not actually storing it in the database. It's just like a spreadsheet that you haven't saved yet. So their address is 123 I don't know Drive. Phone number is 888-555-1212. And the email address is tammyb@gmail.com. And you can expand these to make them look a little bit, have a little bit more data. Okay. So there's Tammy Baker. Let's add another one. I'm going to double click right below it. Tom Smith, 456 Silly Road, 588-444-5567. And Tom Smith at, I don't know, what's another one? Yahoo.com. And now let's go ahead and apply. Oh, there was an error. I guarantee you what the problem was is that it's out of range for column phone number. Oh my goodness. So our design is messed up. We still don't have a good design. And that's because an integer cannot take all of these digits. That's 4, 5, 6, 7, 8, 9, 10. It can't be 10 digits in size. Okay, well, let's go ahead and not save that. And let's change our design a little bit. Let's maximize this so we have a little bit more space. Are you seeing why it's so important to get the design right the first time? So what I'm going to do is I'm going to right click on this and I'm going to delete the phone number, and I'm going to say, I'm going to create a new column called phone area code. I'm going to create another one called phone extension. All right, let's just say phone number. And let's make sure phone area code, we're just going to make that into an int. And we're going to make the phone number an int as well. I think you can have a 7-digit integer. So the area code of the first 3 digits, then you've got the number. Okay, so let's go ahead and save that in the model. Let's say database synchronize. Okay, it's going to alter the table. It's going to add phone area code and phone number. Pretty good. Okay, that looks good. We're going to execute it. We're going to go back to our local instance. We're going to right click and we're going to say refresh all. We're going to right click on customers, say select rows. So we see our new data here. So let's go ahead and add some data. And 888-999-2234. Okay, I'm just going to add one row because let's make sure if this is going to work. And it did. So it added Tammy Baker. Okay, let's add another one. Tom Smith. Let's apply. Also notice we've got our SQL here. I'm going to go ahead and just select this, copy it. And again, I'm doing this for my own education. So you can actually see how the SQL inserts data into the database. That's actually how it's done. Okay. Now, just to prove to me that it's working okay, I'm going to now right-click on payments, select rows. Okay, that's good. There's nothing there. I'm going to right-click on customers, select rows, and I actually have data out there. All right, great. So now let's add a payment method. So Tammy Baker. So let's add a payment method for Tammy Baker. There's her account number, BOA. Credit card. Now we need Tammy Baker's email address. So I'm going to come over here to customer. It's tammyb@gmail.com. Let's put something else in there. Let's mistype it. So I'm going to say tammybx@gmail.com. I'm going to apply. There's another insert. I may want to keep that. So let's go ahead and save the insert for payment method. And I got an error. And the reason I got an error is it says data too long for account type, row 1. Oh, a lot of stuff here. Account type. Oh, yep. Why? If I go back to my model and I look at account type is a varchar 8. And what did I do? I put in many more than 8 characters. So I'm just going to say CC. Apply. Now it says cannot add to child row because there's a foreign key problem. Why? Because we misspelled tammyb@gmail.com. We called it tammybx. So I'm going to get rid of that X. Say apply. And now Tammy has a payment method. And you can do the exact same thing for Tom Smith as well. Now you might say, why would I ever want to have those kind of constraints? Why would I want to make absolutely sure that the email address is right? Think about that question and you'll come up with your own answer. You don't want invalid data in your database. You don't want duplicated data in your database. You want to have perfect, fact-driven, accurate data, especially when it comes to people and their money. Okay, so what are some of the other things that we can do in our diagram? Well, as I mentioned, we could have multiple people at the same address, so maybe we might want to create an address entity right here. If 10 people live at the same house and all our customers, are we wasting a lot of space if we have the same address in every single customer? So what I'm going to do is I'm going to double click on table here. And I'm actually going to edit table 1. There's the table right there. So I could say address. And then within address, I could have number, street name, apartment. Let's just leave it at number and street name, and then let's say a city. Zip code. Maybe even state. And then maybe what we'll do here is instead of having address inside of customer, we actually have like maybe apartment number or room number or something. And then we want to create, so in this case, multiple people can live at a single address. So this was one customer can have many payments. One address can have multiple customers in them. So we're going to have a little bit of a different relationship here. I'm going to click on this little foot with the dotted lines. I'm going to click on customer first, address. Now, one problem with this is that we didn't set up a primary key for the address table. So what should the primary key be? Well, I think the primary key should be number, street name. I think it should be everything. All of this is required. So I'm selecting all of those as primary keys. I'm not going to say unique, but all of them should be primary keys. And now, when I create that relationship, well, okay, it looks like we still have duplicated data here. We've got this, we'll have the same data here as we have in the address. So this is a good example of maybe we don't want to actually use the real data as a primary key. So what we're going to do here is we're going to add another column called address ID. We're going to make that just an integer. We're going to make that a primary unique key, and we're going to turn off all this other. So yeah, when I did that in the model, it didn't look right. We had all kinds of additional data. Okay. This is why you design your database before you implement it. Okay, so let's say customer address. All right, great. So a single address can now have the little feet. A single address has multiple customers. And we're going to get rid of the address. So we don't need that anymore. All right, so the customer has an address that's located at this address entity. So I'm going to go ahead and save that. I'm going to say database, synchronize the model. Now here we might have a little bit of a problem. Okay, so now let's take a look at our data. So I'm going to right click, refresh all. Now we have an address entity, which is great. But I'm going to right click, or I'm going to close my customers, and I'm going to right click on customers, select rows. Well, okay, everything looks cool, but we have a problem. We have invalid address IDs here, 0 and 0. Also, we lost the address for both Tammy and Tom because we added the data. Now think about this. If you had added 50,000 customers and then you decided to make this change, holy Moses, you just lost tons of data because your design was bad. You wouldn't want to do it in this case. If you made a substantial change to your database, like what we just did, we took the address out of customer and we put it in its own entity, you'd want to write a program that you create that address table and then you copy the address from the customer to the table. Ugh. Do you see how important design is? So now we're going to have to re-enter those. Now that's okay. I'm just going to go ahead and enter a new. So street was 1, 2, 3. Oh, that was street name. Street number is 1, 2, 3. I don't know. Drive. I don't know. Chicago. Florida. Oh, I said CA because I'm from California. That should have been state. And the address ID will be 1. Okay, now let's create another one for Tom. 456 Silly Road. Let's say Tom's also in Chicago. And I'm not sure why I said Florida. It's Illinois. And that should be address ID 2 because the address ID is unique. Okay, let's go ahead and add those two addresses. Okay, so I Don't Know Drive is 1. 456 Silly Road is 2. So we're going to go back to customers. Under the address for Tammy is 1. Under the address for Tom is 2. We're going to say apply. It worked out great. So there is a connection now. If I want to get to Tammy Baker's address, I look at the address ID. I go to the address table. I look for address ID 1, and there is Tammy Baker's address. Now you might say, boy, is that a pain in the neck? Well, if you're going to be writing programs, right, in databases, that's definitely something that's very easily done in a program. Now we have a little bit of a problem here. I actually named the column for state incorrectly. So let's see what happens. Instead of California, this should be state. And let's go ahead and save that. And let's see how MySQL Workbench synchronizes that. Again, if I had had that reviewed by somebody, they probably would have caught that error. And what is it doing? Well, it is going to alter table address and change the column name CA to state. So let's go back to our instance. Let's right click and say refresh all. Let's get rid of our address query. Right click on address and select rows, and it did it. So MySQL did it correctly. It changed the column, which I had as CA, to state. Wow, that was so much material. It might be a good idea for you to take a look at this video again and follow along again. But oh my God, long video, but database design is so important. It's so crucial to any kind of enterprise, business, science, every place uses databases. And to make sure you've got the design correct, you've got to absolutely make sure, or to actually, I should say it this way, to make sure you've got a good database, you have to make sure you design it first using a modeling tool like MySQL Workbench. Have somebody review it. We made mistakes in this design. I thought that was so cool to represent what could happen in design of a database. You need multiple eyes on it. You want to make sure it's right. You don't want to build a 100-story building unless you have other people look at your design. Same with databases. And having to write programs, convert data, losing data. Oh my God, you definitely don't want to do that. So, hope you enjoyed this video on getting started with database design. We're going to have much more scientific, much more content-driven videos, but this is a nice little introduction to get you started. Hope to see you in my next video.